The topic of my presentation is about performance tuning with Angular. And let me introduce myself. I'm Manfred, I'm a trainer and consultant, and I'm focusing on the topic Angular. I'm doing nothing but Angular since it went beta in December 2015. And I'm also a Google developer expert, which means that I'm connected to Google and the Angular team. And from time to time I'm writing. My last book was also about Angular. By the way, it's the book with the most ugly cover animal, but anyway, I like it. So let's start with a little picture. Who knows this? Yeah, not most, some of you. It's a 386. Who knows the Intel 386? Okay, yeah, about the half. The hero of my childhood. It is a home computer, and a nice thing of this Intel computer is there was this turbo button. Perhaps you remember it. And when you push this button, then the computer is twice as fast. Of course, the real use case of it was to make the computer slower, to be more compatible with the former version of it, with the 8286. And now the question arises if there is such a turnkey solution for Angular. And as it turns out, yes, there is such a turnkey solution for Angular. There are some quick wins you can use to get a better performance. For instance, you can do bundling. You can also do minification, and you can enable the production mode. In these cases, you get a much better performance when you run your code. And the good things about this is that you don't need to do anything when you are using things like the CLI. You just can create a production build and those things get baked into it. But there are some other things you can do to improve the performance of your application, and that's what I'm talking about here. That's what the contents of this talk is about. I will start with lazy loading and preloading. I will also talk about performance for data binding with OnPush. I will talk about Ahead of Time Compilation, as well as about tree shaking, and I will also talk about caching with service workers. In addition to that, I will talk about server-side rendering. But first things first, let's start with the first topic. Let's start with lazy loading. So a good friend of mine told me that I'm very authentic when I'm talking about lazy things. I have no idea what he meant, but I think it was some kind of compliment, don't know. Anyway, what you see here is the typical structure of an Angular application. You have something like a root module that is bootstrapped. You have several feature modules, perhaps one for each use case, and you have one or several shared modules. And normally, everything is loaded on startup. Of course, that influences the startup time in a bad way, and this is exactly where lazy loading comes in. When you are leveraging lazy loading, you just start with one or with several modules, and then one by one you are loading the other modules you need. When you need the first module, you load the first module. When you need the second one, you load the second one, and so on and so forth. So what does it take to make use of lazy loading? You just need a routing configuration for it. Normally, when it comes to routing, you have a mapping between paths and components. When it comes to lazy loading, you map your path to a module that should be lazy loaded when you activate the route. In this case, when we are switching to the route flights, Angular or the Angular router would load this flight booking module here. For this you are using load children, and load children gets a string with the name of the module file, and you append the name of the module class to this module file name. The name of the module class would be here flight booking module. So that's everything you need to do to get lazy loading to improve your startup performance. Now, of course, the question arises, which route is activated when we are loading this module? And the answer is your lazy loaded module has a routing configuration of its own, and there you could insert a default route, a route without a path or a route with an empty path, and then this route would be activated after the lazy loaded module is loaded into the memory of your browser. I think it's a good time to do some live demonstration. I've prepared a simple example that is about booking flights. And there is this menu item flight booking, and this menu item triggers lazy loading. For this, I have just included this route here, this route into my application with the name flight booking, and as mentioned on the slides, it points to the module as well as to the module class. And in addition to that, there is another important thing. You have to get rid of every reference to this module within your main module. Let's have a look to this. Here we have my main module, my root module. And here I have commented out the reference to the flight booking module. That is vital because, as mentioned, this would prevent lazy loading. The reason for this is a typical bundling solution would follow this reference and would put this reference and everything that could be reached from this reference into the main bundle. And of course, when everything ends up in the main bundle, lazy loading doesn't make any sense. So for this reason, just comment out any reference to the lazy loaded modules. Okay, let's do some diagnostics. You have a question?
Quick question about the path. Does deep linking work with that?
Yeah, deep linking absolutely works. So you can jump to a subroute of your lazy loaded module. Let's have a look to the network tab. Let's trace the files that are downloaded into the browser. I'm reloading here my application. A lot of bundles are loaded, bundles and other files. Then let's clear this and let's switch over to flight booking. And now we see that an own bundle for flight booking is loaded. This own bundle is called after my module. It is called flight booking module chunk. So I think this shows that lazy loading really takes happen here. A drawback of this is that the lazy loading procedure takes some seconds during runtime. When I'm clicking here the first time at flight booking, we see this nifty loading indicator. Okay, I've stolen it from some website, but this also shows that the user has to wait when he or she triggers lazy loading. This is the drawback of this procedure. And this is exactly where preloading comes into play. Preloading means that modules that might be needed later are loaded after the start of the application. And this in turn means that when the module is needed, actually, it is available immediately. What does it take to go with preloading? You just have to define a preloading strategy when you set up your routing configuration. Here I'm calling router module for root to set up the routing configuration for the root module. And as you might know, this method takes a second parameter, object with further parameters for the routing. And there the parameter we have to go with is the parameter preloading strategy. Here I'm using the preload all module strategy, which means that every module that could be lazily loaded is loaded when the application starts up. So, as a matter of fact, when we are using this, first of all the application starts, the user sees the application, and after this, after the application can be seen by the user, after the application is interactive, Angular starts to preload all the other lazy modules. And because of this, those lazy modules get available quite soon. Okay, so much for lazy loading and preloading, let's talk about another thing to speed up the performance of your Angular application. Let's talk about the OnPush optimization technique. And for this, I just want to start with a little demonstration. As mentioned, my application allows to book flights. And here I can search for flights, for instance, for flights that go from Hamburg to Graz, which is the city I'm living in. And then here we have a delay button. And we push this, when we push this delay button, just the first flight here is delayed. So when you look at the first flight, we have something like 0.43, and when we push it again, we have 0.58, and when we push it again, we have 1.13, and so on and so forth. Perhaps you've notified the animation I have put into this application. This isn't because I want to show you how animations work, but this is because I've tried to visualize the change detection mechanism of Angular. Every time such a card blinks, Angular is checking this card for a change. And here we see, even though just the first flight is delayed, Angular checks every flight for a change. And this can lead to a bad performance when everything is checked all the time. Normally that isn't a matter at all, because Angular is generating source code for these checks, and this source code can handle some hundred thousands of data bindings. But in some situations this is just too slow, especially in situations where you are triggering change detections on a regular basis. For instance, when your mouse move event is triggering a change detection event on a regular basis, then you need something else, something like this OnPush change detection strategy. When it comes to OnPush, you can lock down specific components. For instance, here I've locked down my card components, which means that Angular is keeping them for change detection. Angular will only check them for changes when Angular is notified that there might be a change. And what notified means, I will tell you in some slides. First of all, let's talk about how to activate this optimization technique for components. This is the most easiest part of this. You just have to set change detection to the strategy OnPush. When you're using this, then Angular locks down the component, and then Angular is just skipping this component for change detection. Now, of course, the question arises, what do we need to do to notify Angular about a change within these locked down components? And there are two answers for this. The first answer sounds easy at first, but it isn't. The first answer says just change the bound data. Just change the data that is bound to a property via an input binding. And the second answer is notify a bound observable. So let's have a look at the first answer. Here in this example, I have in my parent component an array of flights. And of course, this array consists of several flights, and those flights are passed down to the flight card components. And now, to notify Angular about the change, we have to change those flights. But to gain a good performance, Angular isn't checking whether the first property of the flight changed, the second property of the flight changed, the third property of the flight changed, or the 50th property of the flight changed. Angular is just checking whether the whole flight changed. Angular is checking the object references here. Because of this, Angular can quite easily find out where a change occurred. It just checks whether the object references changed. And this means we aren't allowed just to modify a property, we have to exchange one object for another one. Some people are calling this immutable data structures, when the object itself can't change, but the object itself has to be exchanged by another object. Here we have a demonstration for the second answer I've gave you. We could also bind an observable within the component in question with the async pipe. In this case, the async pipe subscribes for this observable, and the async pipes just triggers change detection every time the observable is coming up with a new value. So let's look at a demonstration for this. I have a tiny secret for you. I'm not changing the objects here, the flight objects. I'm exchanging the whole flight references. Every time I'm pressing delay, a new flight is generated, a new flight with the new date. Because of this, I can easily activate OnPush here. Let's do this. I'm switching to my flight card component. flight-card.component, and here I'm activating the change detection strategy OnPush. Let's save it. Let's wait for the compiler and for the bundling, okay? And let's go back into our application. I'm searching for flights. And then I'm delaying the first flight, and as we are seeing here, just the first card is checked for a change because just the object reference of the first flight has been changed by my application.
Can you show what you're doing in the delay actually?
Of course, we can have a look there. Flight service, flight.service would be the name of this. Okay, this is my delay function. Let's go to Zen mode. And I'm doing this procedure step by step. It's a bit too long. I think you could save some lines of code here, but I really wanted to do this step by step to emphasize on what the idea is behind exchanging the object reference. First of all, I'm grabbing the current flights array. I'm calling it old flights. Then I'm grabbing the first flight of this flight array. I'm calling it old flight. And then I'm taking the date of the old flight, which is just an ISO string, and I'm passing this date with the date constructor. I'm calling the result of this old date. Then I'm calculating the new date. The new date is the old date plus the milliseconds for 15 minutes. And then when I would use default Angular, when I would go with modifying properties, I would do something like this. I would just modify the date property of the old flight. But as mentioned before, we aren't allowed to do this because we have to exchange the whole object reference. Because of this, I'm using this nifty syntax here. This nifty syntax that comes with TypeScript, I think 2.1 or 2.2. This is called the spread operator for objects. Here I'm just creating a new flight, and this new flight gets all the properties of the old flight. All the properties? No, not all the properties, because a little property in the north of France, no, because a little property here is reluctant and has been exchanged. And this is the date. So as you see, using immutables is a bit harder, is a bit more verbose than just modifying properties, but it isn't that difficult as you might have imagined. Of course, I want to stick with immutables. Because of this, I'm not modifying the existing array, I'm just exchanging the existing array. And again, for this, I'm using the spread operator for arrays. The new array consists of the new flight as well as of all the other unmodified flights of the old array. Again, I'm using the spread operator here. It's the spread operator because I'm spreading all the items from the old array into the new array. Not all the items, all the items beginning with the index position 1. Yeah, and then I'm writing new flights back to my flights property. Because of this, Angular just needs to check whether the object reference for the flight array has been exchanged, as well as whether the object reference for the old flight, for the first flight this year, has been exchanged. So this idea isn't that new, to be honest. Perhaps there are some React guys beyond you. To be honest, we have borrowed this idea from the area of React. There are quite similar concepts.
But wouldn't you be able to just replace the first item of the start flights with the new flight?
Yeah, that would be possible in this very case.
Yeah, because NG4 wouldn't check the whole array, but only each item itself.
Yeah, that's a good point. In this very case, it would be enough just to exchange the object reference for this one flight. But when I'm doing immutables, I like it to do immutables at least for the whole use case. I don't want to mix immutables with mutables, because in this case, I have to think too much what Angular is doing during change tracking and so on.
I see, yeah.
Okay, and as we've seen here, just the first card here blinks. Really like this. Could do this all the day. Cool. Okay.
Put in different animations. So.
Yeah.
This is part of the next talk, don't worry.
For the next talk, I will consider this. Okay. One important thing is, when you go with OnPush, this isn't an all or nothing strategy. You can use OnPush just for selected components. You don't have to use it for everything. As mentioned, I don't mix it within the use case, but as a matter of fact, you can just use it for a use case that needs additional performance. Some people are saying, hey, I want to use OnPush and immutables and observables all the time. And in this case, you should have a look at a Redux pattern and at some Redux implementation, for instance, on the implementation NGRX store, which is a Redux implementation with Angular in mind. It has been created of a core team member of the Angular team. Okay, so much for this. Let's go on with the next topic. The next topic is about Ahead of Time Compilation. Perhaps you know, Angular is compiling HTML templates in any way to JavaScript. The idea behind this is that JavaScript can be faster evaluated compared to HTML. And for compiling this stuff to JavaScript, there are two approaches. The first approach is called just-in-time. In this case, you are compiling at runtime when the application starts up. Of course, this is delaying your startup procedure. And then there is ahead of time compilation, which means that the HTML templates are compiled to JavaScript during an additional build step. And there are some advantages, of course, when it comes to AOD. The obvious advantage of this is you get a better startup performance. Of course, you don't need to compile within the browser, so you get a better performance at runtime. But there are also two additional, non that obvious advantages of ahead of time. One of those is you get smaller bundles, because you don't need to include the compiler into your bundles. In this case, you don't need the compiler within the browser, because you are compiling without the browser during the other compilation steps. And the compiler is quite a big thing. The compiler has about the half of the rest of the core framework. It has about 300K, so you can just save this 300K by doing AOT. And there is another advantage that isn't obvious at first sight. Tools can easier analyze the whole code. Of course, when the whole code just consists of TypeScript or JavaScript, it can be analyzed in a static way more easy. And because of this, you can detect unnecessary code within your bundles, within your frameworks, within your packages, and then you can just remove this unneeded code from the bundles. I think every framework has some lines of code, some classes that aren't used by your application. And of course, those classes can then be removed. You also call this tree shaking. You are shaking a tree so that the unconnected branches of this tree are falling down. When I talked about AOD about a year ago, I had to talk about how to configure your build task to do AOD. That was a tricky endeavor. Today, we can just use the Angular CLI. The Angular CLI comes with a predefined compilation step as well as with a predefined compile and build task, and this task contains AOD. All you need to do is to create a production build. And beneath the covers, Angular is using the AOD plugin nowadays. This will change. They have another plugin, but currently we are using the AOD plugin, and this AOD plugin is part of the NPM package ngTools Webpack. And as the name implies, ngTools Webpack is just an add-on for Webpack, and that's why you can use it without the CLI do. When you just have an vanilla Webpack build, you can use it with your Webpack build too. So let's have a demonstration for this. I've compiled my application twice when I've prepared for this talk. I've compiled it once without AOD and once with AOD. Let's start with the not AOD build, with the debug build. Live server entry file index HTML. And here we go. And now let's go into the developer tools. There is this nifty performance stack, and let's measure the start performance of this application. So as you see, this takes a moment.
Did you do something nasty in there to make it specifically slow, or?
No, it's just an ordinary application which is built for debug purposes.
Okay.
So it's really a debug build. And as we see here, this took about 7 milliseconds. 7 seconds, 7,000 milliseconds, yeah. And when we look at this diagram, we see the browser is executing most of the time this yellow task. So what is this yellow task about? This yellow task is about scripting we see here. And when you guess what this scripting is about, what would you say? Yeah, it's about JIT, it's about compiling. Here we see the compiler in action. Here we see that the compiler is just compiling down the HTML templates to JavaScript on startup. So it is always a good idea to repeat such a measurement. Perhaps we get a slightly better performance. It won't be that better, but it could be slightly better the second time. Yeah, it's about 7 seconds, 7 and something, 7.5 or something. Okay, so much for the debug build. Let's start with the production build. Stuff goes down. Let me double check. Here, this is the production build. And here we have the bird. Let's reload this. No. And let's have a look at this, and we see we are ending up with 4 seconds. So let's repeat this. Yeah, now we are ending up with 3.5 seconds. So as you see, we managed to save 50% of our startup time. So I think my application is fetching some metadata from the web, and as my internet connection isn't the best here, this also takes some seconds. When we look at the network tab, there should be a call to a discovery document somewhere. Yeah, here, the OpenID configuration. Okay, so much for this. So I think that shows that everything of us should use ahead of time compilation in production, and that also shows why JIT compilation is not allowed at Google. They have to go with AOD there. There was some question somewhere.
One question is CLI in AOT mode using rollup to do tree shaking, or you still have to do it on your own?
You don't have to do it on your own. They are using Webpack currently. And Webpack since version 2 is doing tree shaking, and it gets better and better with it. But the question is a good one, because I have a nice information for you when you are interested into tree shaking. When it comes to tree shaking, there are some challenges. And the biggest challenge is that most tree shaking tools are quite conservative. That means that they are just removing code when they are sure for 100%, because they don't want to break your application, of course. And the not nice part is that very often they aren't sure. So that means that tree shaking is nowadays not as good as it could be. The tree shaking tools have a hard time to find out what really can be thrown out of the bundle. But there is a good message for this. The Angular team worked on something that is called the Angular Build Optimizer, and this Angular Build Optimizer rewrites the compiled code. It turns out that it just needs some tiny modifications with the compiled code to make the code more tree shakeable, to help those tree shaking tools to find out which code is needed and which code isn't. And this is currently in beta and experimental, but I hope that it will land in the CLI soon. When you look at the current beta version of the CLI, you can try it out nowadays. And I've played around with this. I did some experiments, and I found out that these results are possible. When you look at this slide, I think you see what's the potential of this build optimizer. Of course, the gains differ from project to project, from libraries to libraries, from packages you have downloaded to packages. But as a rule of thumb, you can say about optimization of 50% is possible. I've found this number out with several scenarios. So as we see, tree shaking is a huge deal. We just need to help the tree shaking tools to find out what can be removed more easy. When you want to read more about this, when you want to find out why those modifications help the tree shaking tools, just check out my blog. I have written 2 blog posts about this. The first one is how to use it, and the second one is about what it does beyond the covers. Okay, so let's go to the next topic. The next topic is about caching with service workers. And first of all, we have to talk about what service workers are. And the answer is service workers are just background tasks within your browser. You can compare them to a Linux daemon or to a Windows service, but as mentioned, it runs within your browser. And it is installed by a web application, and the browser can activate and deactivate those background tasks on demand. What has this to do with performance? Well, one exercise, one task they can do is caching. And for this they can do something that sounds quite interesting. They can intercept every request of your website, and then after intercepting those requests they can decide how to respond to this request. For instance, they can respond with the cache, which can be quite fast, or they can respond by using the network, by going out to the network and by fetching fresh data. An important thing about this is that there is the same origin policy in place. That means that a service worker installed by the domain A cannot intercept requests for the domain B. Otherwise, that would be quite dangerous, that would allow for security attacks. And because we can write the service worker as a JavaScript, we can implement some interesting caching patterns that haven't been possible in the past. Caching patterns like cache only, which means the script just takes the cache, or network only, which means the script just takes fresh data from the network. We can also implement something like try cache first, and when nothing is there, use the network, as well as try network first, and when the network isn't available or is quite slow, then take the cache. And as mentioned, you can control these caching patterns because the source code of this service worker is up to you. Using
Service workers are only available in Chrome.
it's partly true. Currently there are free browsers, and since some weeks we know that Service Worker will land in Edge quite soon, and also Safari told that they will have Service Workers. They announced it some weeks ago. That was a really good announcement for everyone who is using Service Workers or progressive web applications. Progressive web applications is this umbrella term, and Service Worker is the central point of these progressive web apps.
More general question, is it a good idea to actually return from the cache, then contact the network, and then update the cache?
That can be a good idea, and it could be another caching pattern, yeah. You can also try to do race conditions and take the result that is the faster one. And anyway, when it comes back from the network, you can cache it. Using service workers directly is a bit difficult because there is this low-level API for them that isn't much of fun. But fortunately, there are some high-level APIs abstracting service workers, and one of those high-level APIs is Workbox. It's quite new. It's directly from Google, or at least from some guys who work at Google, and it allows you to write service worker in a very easy way. Here I have the source code for a simple service worker that is doing caching. The service worker is importing Workbox, then I'm instantiating my Workbox service worker, and then I'm grabbing two caching strategies, the network first strategy and the cache first strategy. And then I'm setting up two routes. The first route is for Angular.at, where my web API runs on. Here I'm using network first, because I want to have fresh data when I'm accessing my web API. And the second route is for the REST. Here I'm just using the regular expression points, which means everything. And here I'm using the cache first strategy. So that means everything but my calls to my web API are processed with cache first. After this, I just have to load this service worker into my application, and then I get the performance gains of caching. Let's have a demonstration for this. First of all, let's have a look at this example here that is not using service workers. And here I'm just simulating a slow network, slow 3G. And here I'm reloading this. And as we see, 3G or slow 3G isn't a fast thing. You need a bit of patience when you are using a slow 3G connection. Yeah. It took about 3.65 seconds until the DOM content loaded, and the overall time it took was 7 seconds. So let's retry this. Yeah, now it took a bit longer. So perhaps you can remember these numbers, or let's just do a screenshot. So this is screenshot for poor man's. And let's switch to our service worker build. The application is started. Let's reload the application. And let's have a look to our application tab here. And here we see that a service worker is running. The service worker with the ID 4433. Okay, so let's simulate a slow network connection. Slow 3G. And let's reload this. No, it wasn't much faster, is that true? So that's somehow a pity. Because it should be faster now, as we are using service workers. Let's go offline. It should also work when we aren't connected to the web. For some reason, it really takes also 3 seconds. As mentioned, it should be faster now, but as I'm offline now, you are seeing that I'm indeed caching, that I'm indeed using my cache. Let's try it again with clear cache. No. Okay, for some reason it isn't becoming faster, but it should. But a very nice aspect of this is, let's just quit our server. And when we reload our application, we see that everything still works, because as mentioned, we are using our cache that is controlled by the application. Okay, interesting. So much for service workers. So when I've prepared for this, there was really a performance gain. No idea why there isn't a gain now. Okay, let's come to a last topic. Let's talk about server-side rendering. Perhaps you are wondering why we need server-side rendering, because now we have client-side frameworks, we have Angular that runs within the browser. So why do we have to go back to the ages of PHP and so on and to do server-side rendering? Well, it's all about pre-rendering the first page of your application. You want to deliver it more fast to the user. And this is about the startup performance the user thinks he sees. It's all about displaying the first page in a faster way. And this is especially important for consumer apps, because consumers aren't patient. When they have to wait a bit longer, they are moving to the next competitor. There are some nice statistics. For instance, when you have a delay at Amazon for just 1 or 100 milliseconds, I think it was 100 milliseconds, then the gross amount goes down about 1%. And 1% of the gross amount of Amazon is a huge thing, I think. So you see, the first impression, the startup performance, or at least their perceived startup performance, is important when it comes to custom applications. Angular in version 4 comes with a baked-in support for server-side rendering. And for this it comes up with this method here. It is called render module factory. And render module factory just gets the module factory of your root module. The module factory is what the AOD compiler compiles out of your module file you are writing. And you have to pass the contents of your index file, the contents of your index.db, of your index.html, not index.db. And of course, you have to pass in your URL. And after this method is just starting up Angular. It is rendering the page in question, the root in question, and then you get back the whole source code, the HTML code, for this pre-rendered page within this then function. So this is leveraging promises, as you might have seen. And now it's up to you what to do with this string. You could save it into an HTML file, or you can just wrap a server process around it and deliver it out to the user. And when you do the later one, then you can, of course, implement server-side rendering with this strategy to speed up the perceived startup performance of the first page. Also for this I have prepared an sample. So let's switch to my sample that is using server-side rendering. Let's shorten the prompt. Let's go to the distribution directory, and here I've just prepared a main server bundle which has been compiled for server-side rendering. I've also wrapped a server-side node process around this, which is calling the method we've seen. And now let's have a look to localhost 80,000. Oh, 8,000, yeah. And perhaps you have seen, for some seconds we saw the word server. Let's test this with a slow network connection, for instance with slow 3G. It takes some time. Sometime. We see the word server on the left. This is the result of the server-side pre-rendering. And after some seconds, after the JavaScript code has been downloaded, executed, and so on, Angular kicks in on the client side. So what you've seen here is what server-side rendering is about. It is just about bridging this gap between the time when the page arrives in the browser and the time when Angular kicks in, when the application gets interactive. And of course, this is a positive thing for the perceived performance of the user. I'm really emphasizing the word perceived, because the application isn't getting interactive more quick. It is just there, it is just displayed in a more fast way.
It's really important with AOT?
It's also important with AOT. Both addresses different things. Because in both cases, when using AOT or not, you have to download, of course, the JavaScript bundles. You have to execute the JavaScript bundles. Perhaps the JavaScript bundles are fetching additional data from the server. Angular has to kick in. Angular has to do client-side rendering. So this is also important when it comes to AOT. For a consumer application, you would combine, of course, both. You would combine server-side rendering with AOT. with lazy loading, you mean?
Yeah, lazy loading.
Yeah,
that's what I
it absolutely works
So
together.
you can also
with lazy loading.
render lazy loaded, deep nested paths in that way and gets into Chapter.
Yeah.
That's interesting.
Yeah, that's true.
I assume there's no possibility to let the server take care of all of the interaction. Like you wanted to target some really old browsers or something.
Oh, is it possible to do everything on server side? No, this isn't a goal of this implementation. Yeah, the goal is just to bridge the gap. Of course, you can do some things without JavaScript here. For instance, navigating from menu item to menu item would work without JavaScript, as everything is also server-side rendered. But things like working with forms or other things, working with drop-down fields and so on, isn't supported when you don't have JavaScript. So the main goal of this is just performance for consumer apps. Saying this, I wouldn't use server-side rendering for business apps, because it is also bringing some additional complexity into play. And because of this, I just would use server-side rendering when I really need it.
I would object a little bit. It depends on the business application. If you have a strong focus on SEO,
Yeah,
then you should definitely do it no
Yeah.
matter which application you're using, because Google really likes this shit.
yeah, that's a good point. When you have a business application that is publicly available and where you have all these things like SEO, then server-side rendering is an important thing. When it comes to intranet applications behind the firewall stuff, then it just increases the complexity. Yeah, good point. Thank you.
What kind of backend solution you work with?
You need some JavaScript backend process, which calls Node.js into play. But there are also wrappers. For instance, currently there is a wrapper for .NET who is doing .NET. Okay.
.NET has an example for doing server-side rendering in ASP.NET Core 1 and 2.
Yeah. It is using ASP.NET Core. And there they are using something that's called Angular services. And what does Angular services do? It is starting a JavaScript process, a Node process within ASP.NET to just start Angular. Yeah, that's a solution. You can also go with both, with an ASP.NET backend or a Java backend or a PHP backend, and you can use, in addition to this, a Node backend just for pre-rendering. So no one prevents you from just using two backends. Okay, so much for this. So there are also some challenges when it comes to server-side rendering. One challenge is that you have other conditions on server-side. Perhaps you've seen it on server-side, there isn't a document object model, of course. And for this you have to take care. A good workaround for this is to use separate services, one for the server side and one for the client side. You can also use the renderer, which is a DOM abstraction within Angular. The renderer does the right thing on both sides, on client side and on server side. On client side, it is leveraging the document object model, the DOM, and on server side, it is just writing into a string. And you have to take care with third-party vendor libraries, because those third-party vendor libraries very often use the DOM directly, or they are using jQuery, which in turn is using the DOM directly. That won't necessarily work on server side. But I have a good message for you. With Angular 5, they are introducing a server-side DOM simulation. And this is simulating the DOM at least partly on server side. So the hope here is to make more third-party libraries available with server-side rendering. They can't, of course, simulate everything, but the hope is to make just more possible on the server side. Okay, so much for this. Was there a question?
Just briefly, the part with the render, that's only if you actually need to do DOM manipulation directly, I guess, right?
Yeah.
So normal template binding just works out of the box.
Template bindings works out of the box.
And with the services, that's also only if you're doing services that do DOM manipulation, I guess.
Yeah, DOM manipulation, or when services are accessing, let's say, local storage or the window object or the location object and so on. In this case, it would be a good idea to have two implementations of your service, one for the server side and one for the client side. Are there other questions so far? Okay. When you are interested into the topic performance tuning, then I have a nice link for you. I have a meta blog article at Medium, a column at Medium, and this column is pointing to several of my real blog posts about performance tuning. Yeah, let's try this out. Here we have some hyperlinks, and perhaps when you say, hey, I want to see how pre-rendering works, what I have to do, what I have to configure when I want to do server-side rendering, you find an article here. As a matter of fact, most of these things are quite easy, but you have to configure a whole bunch of aspects, and you can read about those things here within those articles. So let's come to the conclusion. As we've seen, there are some quick wins. There are some turnkey solutions for performance tuning, like bundling, like minification, like the Angular production mode. And the good message is the Angular CLI is doing for this. Then there is something like lazy loading and preloading, which allows you to improve the startup performance. There is something like AOT and tree shaking, which also allows you to increase the startup performance, and in turn it is shrinking your bundles. There is something like caching with service workers, which should in theory also boost your startup performance. There is something like OnPush with immutables and observables, which boosts your data binding performance. It is just necessary when you have to do change tracking on a regular basis, for instance, when you are triggering the change detection procedure within a mouse move event. And for consumer apps, I would recommend server-side rendering. So that's all. Here you have my contact data. When you have further questions, just write me an email or just send me a message on Twitter. And of course, you will find all my material within my blog in some minutes, and then you can try out the examples, for instance, also the example with the service worker. It should, as mentioned, bring a better performance. Perhaps you try it out and you tell me. So thank you for this and have a nice evening.